welcome to National Training Providers Toolbox Talks. This video is one in a series of Toolbox Talks available on our YouTube channel. Have a look at the others in the series along with our other free training videos covering all sorts of informative, interesting and useful information. Click like and subscribe so we can let you know when new videos are uploaded. And in this Toolbox Talk I'm covering load safety. There's such a lot of information to take in that I've split this video over two parts. So please make sure that you check out the other video called How to Secure Your Load. You're going to benefit from watching them both. Now, legal requirements and common sense require that all loads carried on vehicles are secured, whatever the journey. This is to protect the people involved in loading, unloading and driving the vehicle, together with other road users and of course pedestrians. So this topic covers all aspects of load safety, including the types of cargo that may be carried and how to manage potential risks. So you have a duty to ensure that you understand the fundamentals of load safety. You're aware of the strength of the securing equipment required, that your vehicle is not overloaded, that the load is evenly distributed, and that you check the load regularly during the journey. If in any doubt about the weight of the load that you're carrying, you must proceed to the nearest available weighbridge to check the weight. Ultimately, you're responsible for the load carried on your vehicle, whether you were involved in the securing of the load or whether you weren't. Now, badly secured loads pose a number of hazards, whether it be loads or part loads falling off in transit or during loading and unloading. Loads or part loads moving during transit or during loading and unloading, or even vehicles overturning after becoming unstable when the loads have moved during transit. Now, the risk of any of these taking place must be assessed and appropriate mitigation measures put in place. There's specific principles of load safety. Now, load safety depends upon three factors. Firstly, the customer providing accurate information and preparing the load adequately. Secondly, the operator providing you with the proper load securing devices and of course training. And thirdly, that you accept responsibility for the safety of the load. A load on a vehicle must always be secured by physical restraint and not simply by its own weight. It must be positioned and secured so that neither danger nor nuisance is likely to be caused to any person or property. Safety of a load is not easy, requiring an understanding of modern securing systems involving not only chains, straps and ropes, but also pallets, wrapping and liquid and gas tight hatches. A load can come off the vehicle or out of a container on the vehicle, moved from the position in which it was originally placed, or in the case of a liquid load, maybe even leak. It can also be said that the method by which the load is secured on the vehicle is so inadequate as to be inherently dangerous. Incompetent fastening, failure of the fastening equipment, collapse of some part of the load itself, the way you drive, putting stresses on the load and its fastenings, or overloading the vehicle beyond its capability, they all contribute to loads not being safe. The weight, packing and distribution of the load must be such that no danger or nuisance is likely to be caused to persons, vehicles or trailers on the road. The load must be correctly distributed on the vehicle or trailer body, and a vehicle or trailer should not be used if it's unsuitable for safe loading. It's an offence under the Road Traffic Act 1991 to use a vehicle or trailer on a road or to cause or permit its use when the position or distribution of its load or the manner in which it's secured means there's a danger of injury to any person. Maximum penalty you could receive is a fine of £5,000 plus 3 penalty points and disqualification from driving. Now, dangerous driving is committed when it's obvious to a competent and careful driver that driving the vehicle in its current state would be dangerous. The state of the vehicle for this purpose includes anything attached to it or carried on or in it, and to the manner in which it is attached or carried. The minimum penalty is a licence endorsement and disqualification for at least 12 months with an extended retest, and the maximum penalty is a prison sentence of 2 years. Now, in the case of causing death by dangerous driving, the minimum penalty is disqualification for 2 years with an extended retest, and the maximum penalty is 14 years imprisonment. It's also an offence where nuisance is caused by a load falling or being blown from a vehicle or moving on a vehicle. The load does not have to actually be shed for an offence to be committed. So let's have a little look at the forces on the load. A vehicle moving in a straight line at a constant speed is theoretically in the same state as one that's stationary, and the load will require no restraint to prevent it from moving. This never happens though, does it? As your vehicle will never be travelling at a permanently constant speed or in a perfect straight line. When there's any change in speed or direction, the resultant forces on the load mean that there's a likelihood that it will move in a particular direction, and that is why you'll rarely carry goods without restraints. So what could happen? Movement of the load rearwards towards the tailboard during acceleration due to the inertia of the load. Movement of the load forwards towards the headboard during braking due to the momentum of the load. Movement of the load vertically up and down when going over bumps in the road, or maybe movement of the load in the opposite sideways direction due to centrifugal force when turning corners. These forces, and therefore the tendency of the load to move, are proportional to the extent of the action causing them, and the heavier the load, the more it's likely to move when the vehicle's in motion. Under heavy braking, the weight acting in a forward direction can be equal to that acting down on the vehicle. The way the vehicle's driven can have a significant effect on the magnitude of the forces that are produced as a result of movement. Harsh acceleration, braking and steering movement will all increase the amount of these forces. This is particularly important with steering movement, which through centrifugal force tends to generate sideways movement of the load in the opposite direction to that in which the vehicle's turning. Now with a poorly restrained load, this can result in the load sliding off the vehicle, but there's a danger even with a correctly restrained load. In this case, the vehicle and load can be considered as one unit, and the centre of gravity will always be higher for a loaded vehicle than on an empty one. The distance between the centre of gravity and the tyre contact patch on the road is important because when the combined vehicle and load is acted on by centrifugal force, an overturning action results which is proportional to the centrifugal force and the height of the centre of the gravity. So, the faster the vehicle is turning, the greater will be the centrifugal force, and this can result in the whole vehicle plus its load falling onto its side. A particular danger point is when turning left off a roundabout, when the sudden change of steering direction from right to left can be sufficient to cause the vehicle with its load to fall onto its right hand side, especially if a rear wheel mounts the curb, the road has adverse camber, or maybe if the load shifts inside the body. Now, to oppose these forces acting on the load and to prevent movement, the total load restraint system must produce a force equal to the full weight of the load in the forward direction and half the weight of the load in the rearwards, sidewards and vertical direction. Loads are invariably measured as mass in kilograms, and load restraint devices tend to have their safe working load, their SWL, indicated as force in newtons or kilonewtons. To convert kilograms to newtons, simply multiply the kilograms by 10. So a load of 1,000 kilograms or 1 tonne will require a restraint device with an SWL of 1,000 times 10, 10,000 newtons in the forward direction, or 10 kilonewtons since 1 kilonewton is 1,000 newtons, and 5 kilonewtons in all other directions. Now, all trailer types, apart from skeletal trailers, should have loads secured with chain or strap devices that are appropriate to the vehicle or load and are adequately rated for SWL and regularly tested. Particular attention should be paid to the dangers of high loads that might have to pass under bridges or other structures across the roads. So there's different ways of securing specific loads, which I'm not going to go into in great detail. That's for a different video. So check out the video, how to secure your load, as using the two videos together is going to give you a more complete picture. Don't forget to check out our other free training videos and other Toolbox talks on YouTube as well. Make sure you click like and subscribe so that we can let you know when more informative, interesting and useful information is released. So the total load restraint system will generally consist of combination of lashings secured to anchorage points attached to the vehicle, bulking arrangements including headboards, bulkheads, spigots, transverse beams, shoring bars, etc., which are securely attached to the vehicle, and friction between the load and the vehicle platform. Now, talking of friction, it can play a part in load securing. However, the coefficient of friction is greatly reduced by anything that gets in between the load and the vehicle or trailer floor and acts as a lubricant, making it more likely that the load will move in transit if it's otherwise unrestrained. Friction can be affected by rain, snow, ice, oil, granular materials such as sugar, grain or polypropylene pellets. The forces generated on the load are frequently greater than the friction force between the load and the platform, especially when a vehicle brakes or accelerates, changes direction or travels over an uneven road surface. Consequently, friction between the load and the platform should be regarded as a bonus and should not be taken into account when calculating the lashing force required. You should be provided with the correct securing equipment for the types of load you're carrying. These could be clamps, special bolts, steel wire ropes, chains, webbing harnesses, purpose-made load sheets incorporating webbing straps, nets, ropes or shoring bars. Inside van bodies and similar load containers, specially designed shoring piles used in conjunction with appropriate securing fixtures on the vehicle are suitable. Purpose-built restraining devices should be used only in the manner approved by manufacturers. Tarpaulins, which provide weather protection only, should not be used as part of a restraint system. Sharp or heavy items can break through a tarpaulin sheet. Loads of fine materials such as sand should be sheeted with care, as fine materials of this type can escape between the edge of the vehicle body and the sheet. Palletised loads can be secured using chains, steel, wire or fibre rope, webbing lashings, webbing or rope nets. Although metal restraining devices might be stronger, they might be less convenient and need to be used with end attachments such as shackles, thimbles or similar. A small movement of the load may allow a chain to become slack even when it was properly tensioned at the beginning of the journey. And unless the load is adequately protected, it might be damaged, which could result in permanent distortion of the load and the slackening of the restraint system. Rope or webbing nets are suitable both for securing the cargo to the pallet and for securing the palletised load to the vehicle. Now, to avoid movement of the load, lashings must be properly tensioned at all times using a tensioning device that's specified by the manufacturer. Lashings must not be over-tensioned by the use of levers. It's most important that lashings which provide forward restraint are as near to the horizontal as possible and never at an angle of more than 60 degrees. There should be at least one lashing every 1.5 metres along the length of the load. The complete system of restraints must be arranged so that failure or slackening of one item does not render the rest of the system inadequate. Lashings must be protected against abrasion and cutting by the use of corner protectors or protective sleeves. Nets must be properly tensioned using a tensioning device specified by the net manufacturer. A net must never be over-tensioned by the use of a lever or other device. The efficiency of a net depends upon the size of the mesh in relation to the load. Chocks, wedges and scotches may be used to prevent individual items of a load moving in any horizontal direction. Care must be taken to ensure that they are stout enough and are adequately secured to the vehicle platform. Where it's impossible for all the individual units or packages comprising a load to be packed closely together before any restraint lashings are applied, some form of dunnage must be used to fill any gaps that exist between parts of the load or between the load and the vehicle sides. The use of loose dunnage between the load and the platform should be avoided wherever possible, but where it must be used to support an awkwardly shaped load, it should be secured to prevent movement during the journey. Now, there's a few types of material suitable for use as dunnage: timber of uniform thickness and the maximum possible width, folded cardboard, hardboard, high density foam and airbags. The selection of the best means of securing a load to a vehicle will depend on the type of load to be carried. The number of anchorage points actually used on a particular journey will depend on the weight and dimensions of the load being carried and its location on the platform in relation to the headboard or other additional means of restraint. In flatbed vehicles, small, light items may be carried without additional restraint, providing that the height of the load is less than the height of the side and tail boards, and that there's no risk of the load moving and breaking through any of the boards or bouncing off the vehicle. In any instance where the load exceeds the height of any of the boards, some form of lashing must be used. Where possible, loads should be loaded right up to the headboard, and then each individual item should be chained or strapped. where it's impractical to load up against the headboard, a dummy headboard should be fitted across the vehicle or trailer platform and firmly attached to the chassis frame. Alternatively, blocks, scotches, bolsters, wedges, restraint bars, they can be used to prevent individual items of the load moving in any direction. Care must be taken to ensure that these are adequately secured to the vehicle or the trailer platform. In order to achieve maximum vehicle stability, the load should be placed so that the centre of gravity is kept as low as possible and as near to the vehicle's longitudinal centre line as possible. To maintain the correct balance of axle weight, the load should be arranged on the vehicle so that its centre of gravity is vertically over the vehicle's optimum load point. When a load's stacked, the larger and heavier items should be placed at the bottom and nearer to the centre line of the vehicle, with the lighter ones towards the sides. The lower layers should be strong enough to support others when the vehicle is braking, cornering or accelerating. The weight of heavy loads of small dimensions should be distributed across the vehicle platform by the use of load spreading devices. For maximum stability, the items comprising the total load should be evenly spread to achieve minimum height and be arranged to form a uniform whole so that no excessive stress is applied to whatever restraining devices are used. Where part of a load is picked up or removed during the course of a journey, the effect on the gross vehicle weight, individual axle weights and the securing and stability of the load being carried must be considered both during the initial loading and any subsequent unloading. There's a legal obligation on your employer to ensure the safety of all persons involved in loading and unloading operations, including you. The legislations of the Health and Safety at Work Act 1974 and Regulation 13 of the Workplace Health, Safety and Welfare Regulations 1992. To comply, your employer must have the provision of a safe system of work for loading, moving, unloading, sheeting and safe access onto vehicles. This means that you should have access to the use of safe loading, delivery and unloading plans. Be issued with proper instructions as to the procedures to be followed. You should have proper and competent supervision of loading and unloading operations. And you should receive proper instruction and training in correct methods of load restraint, the correct use of load securing and restraint equipment, and the limitations of such equipment. Now, one means of risk mitigation that your employer might use is to provide you with approved tie-down schemes for each vehicle and load type. These schemes will show where the load is to be positioned, which types of securing devices are to be used, and where the devices are to be positioned on the load and attached to the vehicle. It's your responsibility to follow the tie-down schemes. Department for Transport has a guide called The Safety of Loads on Vehicles, Code of Practice. It's got basic diagrams for the placement and securing of some types of load and detailed tie-down schemes, including a record of the risk assessment for various items of the engineering plan, but operators can develop their own along the same lines. It's worthwhile searching for the document and having a look yourself so as you're aware of the nitty-gritty behind the principles. Hopefully, things are a little bit clearer now. Make sure you check out our other video on how to secure your load. They're both going to be useful using them together. Thanks for watching our Toolbox talk on safety of loads. Don't forget to click like and subscribe so that we can let you know when new videos are uploaded, and check out our other free training videos including more Toolbox talks and interesting and informative and useful videos. Thanks very much. See you soon.